Okay, thank you. All right, so in order to get started today, so I've chosen the 2019 O-level past paper, which I thought we could go into a thorough discussion of each and every question, the paper one as well as paper two. And we can look into a few key concepts and how you can expect questions to come and things like that. So first off, let's move into the MCQ paper. So I believe you all already know about the format and how markings work and all of that. So I'm not going to spend time too much on all of that. So let's directly move into the questions. So if you look at the first question here, it's a biology-based question where they talk about the liver. So as you all know, the liver is considered as the largest organ in the internal part of the body. All right. So obviously, it's a very easy question. It's an organ. All right. Then, when we look into the next question, to maintain the balance of which following cycle is biological fixation important? Now, when we talk about the environment, we have multiple different cycles working together. You have the water cycle, the carbon cycle, the nitrogen cycle. You have so many different cycles that work together in order to help maintain life, whether it's the life of humans, animals, plants, whatever the case. All right. So each cycle works in a different manner. So when you talk about the water cycle, it's something that you all have been learning since the time you all were small. It's a very simple thing where you have water going into the clouds and then water coming back into the earth. But on the other hand, if you take a few more complex cycles like the nitrogen cycle, for example, nitrogen is a very important mineral that is required by the plants. But the problem is now we all know that we have nitrogen in abundance in the atmosphere. Around 78% of the atmosphere consists of nitrogen gas as N2. But the problem is the plants cannot absorb nitrogen. Please mute yourselves, kids. All right. So as I was saying, the plants, they find it very difficult to absorb nitrogen in the gaseous form. So they need it to exist in the form of particular ionic structures. So the main structures that the plants can absorb nitrogen is in the form of ammonium ions, NH4 plus, or as nitrate ions, NO3 minus. So the thing is, these ions need to be formed in the soil due to the activity of different microorganisms. All right. So that entire process, we call it as nitrogen fixation, where these microorganisms work together to somehow, fix the nitrogen or hold it in place in the soil so that the plants can absorb it, because nitrogen is a very, very important mineral for the plants. So therefore, the nitrogen cycle is also one of the key cycles in the atmosphere. So if you look at all of these four cycles given here, there's no fixation as such for the other cycles like carbon, phosphorus, water cycle. They just happen in a cycle. But when it comes to the nitrogen cycle, that is where you have the whole nitrogen fixation taking place. All right. So therefore, in this particular question, in terms of fixation, we go for the nitrogen cycle as the answer. All right, then when we move into the third question, so that's physics for you, which of the following quantities is a vector? That's one of the very first things you learn in your unit 2, I believe. So we know that you have two types of quantities, your scalar quantities and the vector quantity. So the scalar quantities are very simple. They're basically quantities that only depend on the magnitude, things like mass, volume, etc. On the other hand, vector quantities depend not only on the magnitude, but also on the direction. So the best example we come across is displacement, right? So the other three options given here, distance, pressure, work, all of them are considered as scalar quantities. So the answer here is displacement. All right. Then we move into a chemistry question. Which following molecule is composed of the highest number of atoms? So while at the beginning it might look a little complex, it's very simple. You just need to count the number of atoms here. So in this particular compound given here, CH3CHO, you just need to count the number of carbons, hydrogens, and oxygens and give the total. So I believe here you would get a total of 2, 3, 4, 6, 7, right? Here it would be 5. This would be 7 again. This would be 8, I believe. All right. Yes. So therefore, this is your option. Highest number of atoms. Then the fifth question, back to biology. They've given you a rough sketch. This looks most likely to be either ginger or turmeric. Okay, so in terms of underground stems, you all have studied 4 main types. That is the rhizome, the corm, the bulb, and the stem tuber, as given to you in the 4 options. So we know that ginger and turmeric, both of them fall into the category of rhizomes. So there you go with your first answer. If you talk about corms, most of the time any yam type goes into that category. Bulbs are always onions and leeks and things like that. Stem tubers, the most common example we deal with is the potato. The different forms of potato all fall into the stem tuber category. So in this particular case, the option is rhizome. Then we move into the sixth question, where they've given you a set of structures and their relevant functions, and we are supposed to choose the correct relationship. So if you look at the first one, the blood platelets. So platelets, remember, they act as some sort of, how do I explain it? Something like this. Let's say you have a hole in your roof, then you would somehow or the other put something to fill up that gap, right? So it's pretty much the same thing what the platelets do. So whenever you have some sort of a rupture or some sort of a wound inside, let's say your blood vessels due to some reason or the other, you will have a bunch of platelets gathering there to fill up that hole. So that is why your platelets are very important during the blood clotting process. Okay, so if you, let's say you cut yourself and you have blood coming out, at one point the blood coming out stops. That is because the platelets have rushed to that place and they've covered that up. So imagine if you did not have platelets, we would all probably bleed to death if we had even a small cut. All right, that is why when it comes to dengue patients and all of that, we check for the platelet count, because when a person is having dengue, what basically happens is you will have a lot of hemorrhage occurring. Hemorrhage as in blood leakages inside their body. So their blood vessels will rupture and you will have the blood sort of flowing out of the vessels. Okay, so that is a very dangerous condition. So what happens is the person's platelets in their body will immediately rush to those locations to cover those holes up. So then when the platelets get used up, the platelet count drops. So that is why we check for the platelet count when it comes to dengue patients. All right. So definitely production of antibodies is not their function. Then white blood cells, production of antibodies is their function, not transport of oxygen. White blood cells, we know, are basically involved in immunity. Red blood cells, again, it's not phagocytosis. Their job is to transport oxygen. Phagocytosis is a job of white blood cells. It's one type of immune response. So phagocytosis, a very common word we use to describe phagocytosis is we call it as cell eating. That is, whenever you have any foreign substance, let's say some dirt particles, some pathogen, when something gets into your body, some of these white blood cells will immediately rush to that location and they will sort of consume that entire foreign body. And then they will digest it and sort of, completely get rid of it. That is one way in which white blood cells look after your immunity. Okay, it doesn't work all the time, but in certain situations, phagocytosis is very helpful. Then if you look at blood plasma, now, normally blood platelets, white blood cells, red blood cells, those are common terms we are familiar with. As for blood plasma, it's nothing complex. It's basically, now if you were to take your blood, you will be able to easily separate the red blood cells, the white blood cells, and the platelets. Whatever remains is your blood plasma. So all the other transportations like your nutrients, your hormones, your excretory matter, all of those are transported by the blood plasma. So out of these 4 options, the 4th one is the answer. All right. So if anyone has any issues so far, you can always drop a message in the chat if it's urgent, or you can wait until the end of this session. All right. Okay. Then we move into the 7th question. So the relative atomic mass of iron is given to you as 56. Thus, which of the following statements is the correct option? So generally, we know when we talk about relative atomic mass, molar mass, and things like that, we use the unit grams per mole. So if we were talking about iron, it would be 56 grams per mole. So what this basically means is that in 1 mole of iron, you have 56 grams of it. Okay, so if you were to measure 1 mole of iron in a scale, it would give you the value of 56 grams. So based on this data, you need to choose the best option. So the first option says the mass of an iron atom is 56 grams. Now remember, when we talk about 1 mole is sort of like, let's say I'm talking about 1 box of chocolates. So if I say 1 box of chocolates, I'm not talking about 1 chocolate. I'm talking about 1 box of chocolates. All right. So we know in 1 box of chocolates, you have a set number of chocolates, let's say 50. Okay. So 1 box of chocolates has 50. So in this case, 1 mole is like 1 box of chocolates. Inside 1 mole, you have a specific number of atoms present. All right. So remember, if you were talking about the chocolates, whether you buy 1 box or 10 boxes, each box will have 50 chocolates. Just like that, when we are talking about moles, whether I'm talking about 1 mole or 10 moles, doesn't matter. Each mole will have a set number of atoms. That is, after a lot of experiments, they found out that the amount of atoms in 1 mole is this much. 6.022 into 10 to the power 23, what we call as the Avogadro number, because based on the person who found this out. All right. So it doesn't matter whether we are talking about iron or sodium or carbon or whatever element. For 1 mole, it's always 6.022 into 10 to the power 23. Okay. So definitely the first option is wrong, because 56 grams is for 1 mole, not for 1 atom. Okay. Inside 1 mole, you have this many atoms. So definitely the first one is not an option. Second one, a mole of iron contains 56 atoms. Again, no, because we know a mole always contains the Avogadro number. The third one, the mass of 6.022 into 10 to the power 23 iron atoms is 56 grams. Now that is correct. Why? Because we know 6.022 into 10 to the power 23 is basically 1 mole. And we know 56 grams is the mass of 1 mole. So therefore, third one is your option. If we look at the fourth one, the mass of 56 iron atoms is 6.022. No, that is again not the option. All right. So here the answer is the third one. Then we move into the eighth question. Which of the following molecules is made up of 2 covalent bonds? So here you do not see any metals around. So we know that all of them are forming covalent bonds. So if they had given you something like sodium chloride or things like that, you could immediately cancel it out without even thinking about the bonds. Why? Because sodium chloride is forming an ionic bond. So if you have any metal around in one of your options, you can immediately cut it out. You don't even need to consider it, because we know when it comes to metals, if they are found in the pure metallic form, they have metallic bonds. If not, if they are found with some non-metal like sodium chloride, it's an ionic bond. So if you need to look for covalent bonds, it needs to be a 100% non-metal situation. So in this particular question, unfortunately, all 4 of them are total non-metal. So we need to check each of them. So if you were to talk about chlorine, we know in terms of chlorine, if you were to draw the structure, the Lewis structure, this is how it would be. So this is just 1 covalent bond, therefore not the option. When you talk about methane, we know you have carbon with 4 hydrogens, so 4 bonds, again not the option. HCl would be like this, again not an option. But when it comes to water, you have H2O. So this is the option. All right, so therefore answer 4. Then we move into the 9th one, coordination of movements and equilibrium of the human body. All right. So when it comes to the nervous system, under your central nervous system, we know you have the brain, and under the brain, you have studied about 3 main parts, the cerebrum, the cerebellum, and then the medulla oblongata. All right. So the cerebrum is like the larger portion of the brain. So that is where a lot of activities are controlled, like your speech, your judgment, your emotions, the way you understand languages, how your body controls temperature. All of that is controlled by your cerebrum. In your cerebellum, sometimes we call it the small brain. It's right below the cerebrum. So that is mainly involved in helping you to maintain a balance. Okay, as in now when you walk or bend or sit or something, to make sure you do it properly without falling over or things like that. That is the main job of the cerebellum. And then when it comes to the medulla oblongata, it controls things like your heartbeat, your respiration, certain involuntary functions like blinking and things like that are controlled by your medulla oblongata. So in this case, they've spoken about movement and equilibrium. Equilibrium as in a certain balance. So therefore, we are talking about cerebellum here. Option 1. Let me check the chat. Does anyone have any issues? Yeah. Let me see. What is the function of blood platelets? Is it the production of antibodies? No. The production of antibodies is the function of the white blood cells. All right. Blood platelets, like I told, their function is to help in blood clotting, as in to stop the excess bleeding through blood. All right. And then I believe there was another question. Let me quickly check the chat. How to identify whether it is an ionic bond or covalent bond. Okay. So when it comes to ionic bond, remember it's a combination of metal plus non-metal. Sodium chloride, potassium chloride, potassium hydroxide. So what do you have there? You have a metal potassium and you have the non-metal chloride. Okay. So that is how you identify an ionic substance. Any ionic substance will always have one part metal, one part non-metal. When it comes to a covalent bond, it's always 100% non-metal, water, N2, O2, all of that. Okay. All right. Then the 10th question. Consider the following statements on various processes taking place in a plant. Okay. So statement A, plants emit carbon dioxide only during the night. So now we know there are two main processes that take place in a plant body with regards to gases. One is respiration and one is photosynthesis. So respiration is something that is not only there in plants, but there in all organisms. And for respiration, whether it's a plant or animal, it doesn't matter. We all take in oxygen and give out carbon dioxide. But when it comes to photosynthesis, it's something that is specific to plants and certain organisms like algae. So when it comes to photosynthesis, it's the opposite of respiration. You take in carbon dioxide and give out oxygen. So another difference between respiration and photosynthesis is that, remember, respiration is something that is important for us to survive, right? I mean, breathing is important. So therefore, respiration happens at all times, throughout the day, throughout the night, it happens. But when it comes to photosynthesis, remember, light is a must for photosynthesis. So therefore, photosynthesis only happens in the daytime, not at night. Okay. So the first option, plants emit carbon dioxide only during the night, is wrong. Remember, plants emit carbon dioxide when they respire. And remember, like I said, respiration happens in the day and the night. So since the word only is there, option A is wrong. Then when we look at option B, plants emit only oxygen during the daytime. Again, remember, during the daytime, you will have both respiration and photosynthesis happening. So they will give out oxygen due to photosynthesis, but that's not the only thing they give out. They will do respiration and they will give out carbon dioxide as well. So again, because of the word only, option B is wrong. So now if you look at your answers given, you don't even need to look at the C and D. You can directly choose your answer as 4. Okay, so when you get questions like this, don't spend too long, spending time to read all the questions when you have a very obvious answer like this. Anyways, option C says gaseous exchange in plant leaves mainly occur through the stomata. So we know stomata are the tiny pores that you have, especially on your leaves, through which the gases can come in and out. Basically, those are like the doorways. All right. So most of the time it happens in the leaves. you have a certain amount of stomata in the stems as well, especially the green color stems. They do have a bit of stomata, but it's prominent in the leaves. So statement C is true. And then when we look at statement D, gases entering the plant leaves diffuse into the cells through the intercellular spaces. So if you talk about the cell structure of a leaf, there you have, this is your epidermis, then you have your stomata, you have your cells, and underneath you have all your plant cells gathered here, but they're not tightly packed. You have certain, spaces available, which help the gases to travel through. That is what we call as your intercellular spaces. All right. So therefore, that is also a true option. So therefore, it's option 4. Okay. Let me see if there's a question. One question related to relative atomic mass. Okay. What's the difference between two covalent bonds and double bonds? Okay, let's go into the first doubt. Can you do and show one question relevant to relative atomic mass? Okay. Let me see. Okay, so should I go into your book? You can look into that itself. I think it's chapter 7, if I'm not mistaken. Yeah. Okay, let's take this particular question, the third one here. All right. So now in this particular unit, that is this Avogadro number, you study about relative atomic mass, relative molecular mass, molar mass, 3 different terms. Then you've studied about the Avogadro number in this particular lesson. And finally, you study about moles and the mole calculation. So those are the main things that fall under this particular lesson. Remember, relative atomic mass, relative molecular mass, molar mass, they're all big terms, but actually they're all the same. Only thing is, when we talk about relative atomic mass or relative molecular mass, we don't use the unit. But when we talk about molar masses, we do use the unit grams per mole. That's the only difference. Otherwise, it's pretty much the same. So don't get it confused. If you get one word if you're used to molar mass and you get relative atomic mass, don't get confused. It's all the same thing. Okay, so in this particular question, Roman number 1 says, what is the amount of substance? Again, remember, amount of substance. Whenever you come across these words, amount or amount of substance, they're always talking about the number of moles. Okay, amount correlates to number of moles in this sort of question. So what is the amount of substance in moles? So sometimes they will specify if it's in moles. Even if they don't, please remember that amount always means the moles in this particular situation. So what is the amount of substance in moles in 12 grams of magnesium? So the mass of magnesium is given. Whenever you get a question, please note down the data that is given to you, because each and every data is given to you for a reason at your level. Okay, so magnesium's mass is given, and you will also be given the relative atomic masses. Relative atomic mass of magnesium is 24. So we know the equation. N equals simple M over capital M, that is mass divided by the molar mass. So that would be 12 over 24. You would get 0.5 moles of magnesium. All right. Then what is the amount of substance in moles in 10 grams of calcium carbonate? It's pretty much the same thing. Molar mass of calcium carbonate, don't worry, you will be given. It's 100. And the mass is also given. You just need to do the division. And if you look at the third one, these are the ones where you tend to get a little confused. How many molecules are there in 5 moles of carbon dioxide? Now remember, when we did that earlier question, I told you all that 1 mole means 6.022 into 10 to the power 23. Okay. Now, let's say I'm talking about 1 mole of carbon. 1 mole of carbon. And at the same time, I'm talking about a different situation. 1 mole of, let's say, carbon dioxide. 2 different situations, all right? In one situation, remember, carbon is an atom. In the other situation, carbon is a carbon dioxide is a molecule. So two different situations, but still it's 1 mole. So because it's 1 mole, remember the number won't change. It will always be 6.022 into 10 to the power 23. But remember, if you're talking about atoms, if you're talking about 1 mole of atom, we say 6.022 into 10 to the power 23 atoms. If you're talking about 1 mole of molecules, we say 6.022 into 10 to the power 23 molecules. That's it. Okay, so if I'm talking about 1 mole of carbon dioxide, in 1 mole of carbon dioxide, I will have 6.022 into 10 to the power 23 molecules of carbon dioxide. All right. Okay. Then, now going back to the question, how many molecules are there in 5 moles of carbon dioxide? That's pretty simple now. So I told you 1 mole has this much of molecules. So for 5 moles, just multiply this thing by 5. All right. Then how many water molecules are there in 4 moles of water? Again, simple. 1 mole of water, 6.022 into 10 to the power 23. So for 4 moles, just multiply the entire thing by 4. All right. And then finally, what is the mass of 2 moles of urea? So in this situation, they've given you the number of moles. So N is done. Molar mass is always given to you for urea. I think it's 60. So you can substitute this and this in your equation and find M. All right. So hope that clears your question. Then I believe there was another question. Let me see. What's the difference between 2 covalent bonds and double bonds? 2 covalent bonds and double bonds. Okay. Remember, when it comes to ionic bonds, we don't talk about double bonds or triple bonds. When it comes to ionic bonds, we know ionic bonds is always a give and take policy. If I have too much, I will give. If someone doesn't have any, they will accept it. That's a give and take policy. When you talk about covalent bonds only, we talk about double bonds, single bonds, triple bonds, all of that. So remember, double bonds are just one type of covalent bond. That's it. There's no difference as such. Double bonds are also covalent bonds. Okay. And then why is A wrong? Question number 10. Let me see. Oh, plants emit carbon dioxide only during the night. If the word only is not there, that would be correct. Okay. Because carbon dioxide is emitted during respiration. Imagine if plants respired only at night, you would have all dead plants by the evening. Why? Because if they don't respire in the morning, by evening they will be dead. So therefore, they need respiration to happen all the time. So you can't say they emit carbon dioxide only at night. Okay, so I hope that answers your questions. All right, so moving on into the 11th one. The acceleration due to gravity on the Earth's surface is 10. The acceleration due to gravity on the surface of the moon is 1/6. This is a very common question. If the weight of a man on Earth is 600, how much is his weight on the moon? Now remember, there are two things you all need to remember, two words actually. One is mass, one is weight. So now whenever we go to the doctor or something, when we check our weight, it's actually not the weight we are checking, because the scale gives it to us in kilograms, right? So we are actually checking the mass. So next time, don't use the word weight. Okay. So the mass of a person never changes. Whether you go to Earth or the moon or the Jupiter or even the sun, your mass is never going to change. If it says 60 kilogram, you will always be 60 kilograms. Okay. What changes is your weight. Because what is weight? Weight is basically, if I were to talk about the maths part of it, weight, you get weight by multiplying your mass and your acceleration due to gravity. Now, what changes here? The mass, I told you, never changes. So the acceleration due to gravity is what changes. So Earth has a different value, Jupiter has a different one, the moon has a different value. So that changes. So based on that, the weight can change. Okay. So if we talk about, let's say, a person having 600 Newton weight, equation is weight equals mass into acceleration due to gravity. Let me say G. So here we had 600 Newton. We do not know the mass. Mass is not given. Acceleration due to gravity on Earth is given as 10. So using this, we can find the mass as 60 kilograms. Now remember, 60 kilograms is the mass, and that never changes even if you go to the moon. Now we are going to all right. Now we're going to find the weight of the person in the moon. So again, use the same equation. Weight equals mass into gravitational acceleration. Mass is 60. That never changes. What's your gravitational acceleration? They say that it's 1/6 of the Earth. So if Earth is 10, in moon, it's 10/6. 1/6 of that. Okay. You can do it like this also, 1/6 of the Earth. So if you were to continue this calculation, you would get 100. All right, so this is the weight of a person on the moon, 100 Newton. So that's option number 2. Then the 12th case, deficiency of which vitamin causes anemia, that's vitamin B. That's pretty straightforward. If you know those tables at the end of your first lesson, you're good to go there. Beriberi, anemia, dryness in your skin, all of that is because of vitamin B. 13th one, in which part of the female reproductive system does fertilization occur? Fertilization always occurs in the fallopian tube or the oviduct. So we know when it comes to the female reproductive system, the egg is released from the ovary into the fallopian tube, and then the egg will, continue its journey all the way to the uterus. Along the way, if there is a sperm, if the sperm manages to meet the egg, they will undergo fertilization. This will happen in the fallopian tube, not anywhere else. Okay, so that is option 3. Then what is the mass of glucose required to make 500 cubic centimeters of a glucose solution of concentration 1 mole per cubic decimeter? So when it comes to this, first of all, mark down the data given to you, volume given, concentration given, molar mass given. What are the 2 equations you all have studied related to this particular lesson? C equals N over V, and also N equals M over capital M. Okay, so here you can first use this equation because the C is given, the V is given, we can find N. Then your N value would be 0.5 moles. Okay, then use this over here. N is there, M is already given. You can find the mass. Mass would be 0.5 moles multiplied by 180. So you would get 90 grams. That is the mass of your glucose. Okay, so that's option number 2. Then the movement of an object during 25 seconds is illustrated by the velocity time graph given. Select the correct statement about this particular motion. Okay, so here you can see during the first 10 seconds until this point, there's an acceleration. Then you have a constant velocity motion where the vehicle doesn't change its velocity. And then finally, it slows down, decelerates, and comes back to 0. Okay, so this is the overall motion. So retardation is basically another word for deceleration or deacceleration. Different people use different words, but just make yourself familiar with all 3 because you never know which word you will be given. All right, so the retardation of the object is 2. So when you're talking about retardation, we need to do it for this part. So if we were to calculate the acceleration here, we know acceleration is final velocity minus initial velocity. Final is 0, initial is 10. Divide by the time, 25 minus 20 is 5. So you would get minus 2 as your acceleration. So deceleration would be plus 2. So therefore, the first option is correct. We don't need to go into the others even, but let's just go into it and see what exactly is wrong there. So the second one, the displacement of the object is 0. Remember, a velocity time graph, if you talk about it, the area under the graph will give you the displacement. So if you calculate all of this, calculate for these 2 triangular parts and then this and add them up, you would get somewhere around 175 meters, which is definitely not 0. So that's wrong. Third one, acceleration is 10. No, acceleration is this part. Acceleration would be 10 over 10, which is 1, not 10. An object has moved 20 seconds at a velocity of 10. That is, they're talking about this portion. So that is not 20 seconds. This is a period of 10 seconds. 20 minus 10 is 10. All right. So therefore, that is also wrong. The answer is the fifth one. Okay. What's the question? If they ask how many molecules, should we mention the unit? You just need to say, so if they ask how many molecules, let's say you have 6.022 into 10 to the power 23, you write 6.022 into 10 to the power 23 molecules. That's it. You don't have any unit as such for those, right? If they ask you for atoms, you give the number and put the word atoms at the end. Okay. How many molecules are there in 5 moles of carbon dioxide? So remember, Safia, 1 mole of carbon dioxide has 6.022 into 10 to the power 23. It doesn't matter if it's carbon dioxide or nitrogen or whatever you're talking about, that number won't change. So for 5 moles, just multiply it by 5. Okay. Can you explain the 15th quiz again? It is the 15th one. Oh, this velocity time graph. Okay, so here you have a particular object that is traveling with a particular velocity. So that has been given to you in the form of a graph. So the graph consists of 3 parts. This is your acceleration period. This is constant velocity. This is your deceleration. Okay, so you need to look for the correct option. So if you look at this part, this is your deceleration part. You can calculate it. You would get deceleration as 2. Final velocity minus initial velocity divided by time. You're going to get your value, which is 2. So the first option is already given to you. You can go for that. Displacement of the graph will be basically the area under the graph. So there is a value, right? So you can't say it's 0. Acceleration is also not 10. If you calculate for this part, the acceleration, it's 10 divided by 10, 1. And velocity of 10, that is the fourth answer is talking about this portion of the graph. So this is taking place not for 20 seconds, but for 10 seconds. Just because you see the 20, don't get confused. 20 minus 10 is 10 seconds. Okay, so therefore, answer 1. Okay, is that it? How to find the atoms in a compound? Okay, so it depends on the compound that you're given. Okay, so let's say they give you a random compound like glucose. So even if they give you a random compound like glucose, so these are the possible questions you can be asked. C6H12O6. So this is glucose. So one question they can ask you is how many atoms are in this compound? How many? Just count. 6 carbons, 12 hydrogens, 6 oxygens. Add them up, you will get how much? 24. Altogether, this has 24 atoms. This is one question you can get. Another way they can ask you is how many, let's say, if they give you something like you have 3 moles of glucose. Find the number of molecules. So remember, 1 mole of glucose has 6.022 into 10 to the power 23. For 3 moles, just multiply that value by 3. Those are the possible questions you can get with regards to a big compound like that. Okay. Displacement time graph, how to find the motion. Displacement time graph. So if you were to talk about, let's just say this is displacement. So the unit will be meter. Time. So then we will talk about velocity. If it's a velocity time graph, remember we always speak about acceleration. If it's a displacement time graph, we will speak about velocity. And remember, when it comes to a velocity time graph, the area under the graph will give you the acceleration. If it's a, the area under the graph will give you the displacement. If it's a displacement time graph, the area under the graph will give you the velocity. Just keep those points in mind, and then pretty much is the same. Okay. Then the next question. In which part of the alimentary canal is the enzyme lipase added to food? So lipase, we know, is a particular enzyme that works on the lipids. So when it comes to food, you start it from the mouth, that is the buccal cavity. It travels through your esophagus, reaches your mouth, your stomach. In the stomach, you don't have much digestion, but rather you have a lot of the food is sort of blended around and you have it mixed with HCl and pepsin and all of that. But the main digestion happens in your small intestine, especially in the beginning part, the duodenum. So there, your pancreas will release a lot of different enzymes directly into the duodenum. So one type of enzyme is the lipase. You have lipase, maltase, amylase. A lot of them are released inside the duodenum. Then the food is mainly digested there and it's directly absorbed into your body from there. Okay, so therefore the option is duodenum. Then given below is the balanced equation relating to decomposition of potassium permanganate. How much is the amount of moles of potassium permanganate that should be decomposed to produce 3 moles of oxygen gas? So remember, whenever you talk about, whenever you get calculations with regards to chemical equations like this, the most important thing you need to do at the very beginning is to balance the equation out. If you don't balance it, all your calculations are going to go wrong. So then balance it. So here you are lucky, they've already given you the balanced version. Okay. So in this question, they've told you that how many moles of potassium permanganate, so that is here, should be decomposed to get 3 moles of oxygen. Okay. So they've given you the number of moles of oxygen. Based on that, they want you to find out the number of moles of this. Now remember, here it's very simple. We use a ratio method. All right. Ratio, in math also you've studied about ratios. Where it's a form of connecting two things. So here they're building a connection between oxygen and potassium permanganate. So let me write it down. So KMnO4 is to oxygen. So how do you build the ratio? You just take the number in front, the coefficient, and put it. So in front of KMnO4 you have a 2. All right, so that comes here. In front of oxygen there's no number, so that means it's a 1. So this is the ratio between KMnO4 and oxygen. So that means KMnO4 is 2 times oxygen. So that particular relationship applies to any number of moles. So if you have 3 moles of oxygen, the number of KMnO4 is always twice of that. So KMnO4 will be 6 moles of KMnO4. Remember, this ratio method, you can only apply it for number of moles. If they give you the mass of oxygen, let's say, and ask you to find the number of moles of this, you can't do that. Then you need to find the number of moles of oxygen first, and then only use the ratio. Remember, the ratio is only applicable to number of moles, all right? Not to mass or concentration or volume or anything like that. So based on the ratio, you simply find the number of moles of KMnO4. So that is option 4. Then we move into the 18th question. There are 3 wires of equal length with uniform resistance. Illustrated below are 3 instances in which the 3 wires are connected between the points X and Y in the same circuit where the first wire is connected. So yeah, as you can see in this first instance, you just have one big resistance. Second one that is broken and connected in parallel. Third one, it's again broken into 3 and connected in parallel. So the bulb connected to which circuit lights the brightest? Remember, for the bulb to light up in a very bright manner, it means there's more current passing through. Only if you have more current passing through, it will be very bright. So remember, for more current to pass through, it means there should be less resistance. Right now, just think of some sort of a VIP building. So you will have multiple security guards. So if the security guards don't do their job properly, you will have more people managing to get inside. Okay, then the crowd going inside is higher. But if they're very strict and all of that, then the crowd going in is less. This is pretty much the same thing. When you have a very high resistance, it means less current is allowed to pass through. So the bulb is not going to be very bright. On the other hand, if your resistance is very low, that means more current will pass through. Your bulb is going to be bright. So in this question, they're asking us, in which circuit is there going to be the highest number of current passing through? Okay. So since they haven't given you values, sometimes it tends to get a little confusing, but you can always put your own values and try to figure it out. So let's just take a simple number. Let's say we take 3 ohms. Okay. So in this particular situation, let's say all of these resistors are of 3 ohms. So in this particular case, the resistance for this entire circuit is 3. Second one, this is 3, this is 3. Then if I do the calculation, if you do 1 over 3 plus 1 over 3, remember it's a parallel circuit. So 2 over 3, therefore R is equals to 3 over 2. That is 1.5. So definitely the second instance having higher current than the first one. If you look at the next one, again, let's say 3, 3, 3, then 1 over 3, 1 over 3, and 1 over 3. It will be 3 over 3. If you simplify again, 1 over 1. So R is 1. So you can see that the smallest resistance is there in the third instance. So therefore, the third instance only is going to show the brightest bulb. Okay, so that is option number 3. Then if we go into the 19th question, consider the following substances. So you've been given solid sodium chloride, molten, and aqueous. Which of them conduct electricity? So solid is when you have it in the salt form, you know, the salt that we use in the kitchen, the salt crystals, that is basically solid sodium chloride. Molten sodium chloride, molten is when you manage to melt it and only have sodium chloride liquid form. 100% sodium chloride, no water. That is the word molten. And then aqueous is always when it's mixed with water. So we know sodium chloride is an ionic compound. When it comes to ionic compounds, we know that their molten forms conduct electricity, their aqueous forms conduct electricity, but the solid forms do not conduct electricity. Therefore, that is option number 3. So now what is the reason behind this? Why is it that solids can't conduct electricity, but the molten and aqueous forms can conduct electricity? So for that, you need to look into the structure. So let's take sodium chloride ionic form. So if you were to take the ionic form, I'm sure you've already seen the lattice structure of sodium chloride. This is basically how it looks. So here you can see that all of them are perfectly fixed in position. They're not moving, nothing is happening. They're all perfectly fixed in position. Remember, when it comes to electricity, for electricity to, be able to pass through, you need some sort of a movement. Only when particles are moving will electricity be able to travel through. So in solid form, there's no movement. So definitely no electricity. But when it comes to B and C, those bonds are broken. They're just lying around these ions. So therefore, they can move around. So therefore, they conduct electricity. Okay, so that's option number 3. Then we move into the 20th one. When supplying electricity to an electronic equipment, it may get damaged if it's connected in a reversed manner. So which diagram illustrates correctly how a diode should be connected? So if you look at this, you need to have the forward biasing. That is the correct way of connection. So this is how you connect it. Only then the electricity can travel through. This is wrong. This is also wrong because this is breaking through, and then, you would need to travel like this again, which is not possible. This is also not possible. This is the ideal way of connecting your electronic equipment to make sure it works. Okay. So therefore, that is your first option, the forward biasing option. Then you have your 21st one. No doubts so far, right? Okay. It was found that you have an aqueous solution of some compound called HA. So that has H plus ions and A minus ions. And remember, because it's an aqueous solution, you have OH minus ions as well. Why? Aqueous means water. So the water provides the OH minus ions. And along with that, you also have some undissociated HA. Okay. So the pH is less than 7. That means it's an acid. Which of the following statements is true? So therefore, directly cut off option 4 and option 3. This is like what we call as the elimination method. Before you look into the actual answer step by step, as soon as you see the most obviously wrong ones, cut them out. So now we are left with 2 answers. We know it's an acid. That's why its pH is less than 7. Now we need to decide whether it's a strong acid or a weak acid. Remember, when it comes to a strong acid, we know that they will fully dissociate. something like HCl. You won't have any HCl remaining. It will all be H plus and Cl minus. But in this particular situation, the question says you have some undissociated particles as well. So therefore, it has to be a weak acid. A weak acid only will give out H plus, but will retain some of its original structure as well. So therefore, HA is a weak acid, option number 2. All right, then we move into the 22nd question. Several species of animals and the number of animals belonging to each species identified by a group of students in a study are given as follows. What is the number of animals which belong to the phylum Arthropoda? So we know Arthropoda belongs to the invertebrate category, where you have all these insects and scorpions and crabs and all of them falling into the category of Arthropoda. So if you were to include that, butterfly is an insect, spider is an arthropod, scorpion also falls there. So that would be a total of 8. Okay, snails are molluscans, and the leeches fall into the annelids. All right, so that is going to be option number 8. Pretty straightforward if you have an idea about the examples falling under each phylum. Then 23, they've given you the atmospheric pressure at sea level and the area of the tympanic membrane of a man, that is there near your, inside your ear. Okay, so what is the force exerted by the atmospheric pressure on the tympanic membrane? So that is pretty straightforward. You have your equation, you know, you have 2 equations for pressure. One is H rho G. This is mainly when you talk about fluids, that is liquids or gases. When you talk about solids, we go for F over A. So here we have P and A. It's a matter of multiplying these two to get your F, which will give you 5 Newton. Okay, so option number 1. Then the power supplied to a primary coil of a transformer of 100% efficiency is 200 watts. So if the voltage across its secondary coil is 10 volts, what is the current flowing through the secondary coil? So they've given you the Vs. They want you to find the Is. They've given you the power during the primary coil. And they've also told you that it's 100% efficiency. That means there's no loss. Whatever comes into the primary is going out into the secondary. Okay. So based on this, you need to find out the Is. Now the common equation you have studied when it comes to transformers is this. VPIP equals VSIS, primary versus secondary. So in this case, you have this one. You need to find this one. But the question is, both of these are not given to you. Okay. But you also have studied another equation like this. I'm sure you remember. Power equals VI. This is another equation that you have studied. Okay. So in this case, instead of this V and I, what do we put? We directly put the power of the primary coil. We can write it as power of the primary coil equals voltage of primary coil into current of primary coil. That is what is happening over here. Okay. So we already have the power of the primary coil. We know Vs. Now we can find Is. So power of the primary coil is 200. Vs is 10. Therefore, Is would be 20 amperes. That is option number 2. All right. So that is the 24th question. Then we move into the 25th one, which polysaccharide contained in plant cells helps prevent constipation. Now we know when it comes to a balanced diet, we include carbohydrates, proteins, lipids, all of that. And we also include fibers in a certain quantity, things like bananas, peppers, apples, guavas, glass of water. They all help with your constipation, to prevent constipation. Okay, so why do you think a lot of these fibers consist of fruits like bananas and mangoes and things like that? Because you have a lot of cellulose in there, because they're from plants. We know plant cells have cellulose. So these plant products have a lot of cellulose in them. So cellulose helps to prevent constipation. Why? Because it's a good fiber. Okay, so therefore, it's the third option, cellulose. Then we move into the 26th one. What is the constituent mostly present in the urine of a healthy person? That is going to be water. 96% is water. When it comes to, since we're talking about a human, they also have urea around 2%. Salts are also there. Uric acid is very little because uric acid is mainly there in animals like the birds, the reptiles. They only have uric acid in their urine. When it comes to humans, you have water, and then you have a bit of urea as well. Okay. Then 26, it's option 1. Okay. 27, what is the polymer that contains carbon and hydrogen only as the constituents? So when it comes to rubber, we know vulcanized rubber. Vulcanized means there's sulfur in it. So definitely not an option. Polythene has only carbon and hydrogen. So that is your answer. Cellulose, we know, is a type of polysaccharide. That is a carbohydrate. We know carbohydrates are made of carbon, hydrogen, and oxygen. So again, fourth one is not an option. If you look at Teflon, Teflon is basically carbon and fluorine together. I'm sure you've seen things like this. 4 fluorines connected. The one in your non-stick pans and all of that. That's Teflon. So definitely not an option. So it's the second answer there. 28, what is the equipment that works using the force exerted on a current carrying conductor placed in a magnetic field? That is your direct current motor. If I show you this picture, you took it from your book. So this is a simple setup that they were showing in one of your experiments where you have your battery. You fix a magnet to both ends to create a magnetic field. And then what happens, this is your conductor, a wire coil. So according to this, due to the presence of the magnetic field and the current passing through this, there's going to be a force exerted on this coil and the coil is going to rotate. See, depending on the direction of your magnetic field, depending on the direction of your current, the coil will rotate in either clockwise or anti-clockwise direction. But here they're not asking us the direction, they're just asking us about the force. So therefore, the option is the fourth one, direct current motor. All right, then the 29th question. Select the false statement from the following statements. Fractional distillation is used to refine mineral oils. That is very true. When it comes to these crude oils and things like that, fractional distillation is the best way to separate and get all your petroleum products, your diesel, your kerosene, your jet fuel, all of that. You do it through fractional distillation. Steam distillation is used to extract cinnamon oil. Again, true, because steam distillation is used to get all your essential oils from your plant products, cinnamon oil, clove oil, eucalyptus oil, whatever, all those set of oils via steam distillation. Solvent extraction is used to extract medicinal extracts and potions. Yes, along with steam distillation, solvent extraction is also another similar method used. Then when it comes to chromatography, the chromatography that you all have studied is paper chromatography, the simplest form of it. So here it says chromatography is used to separate a mixture of volatile components. No. Remember, volatile components are things that evaporate quickly, like, cologne and alcohol and things like that. So paper chromatography is not a very good option because, you will, when it comes to chromatography, what do? We basically, you need to take a jar. You need to dip a paper inside and put a few drops of your solutions and you keep it like that. Okay. And you need to keep it closed for a few hours at least for an hour or two. Then if it's a volatile component that you're dealing with, by the time you check the experiment, everything would have evaporated and disappeared. Okay. So when it comes to paper chromatography, volatile components are not a good option. All right. So if you all are wondering what chromatography is actually used for, chromatography in the book, it's a little difficult to understand the way it's given. But basically, chromatography, remember, it's a very outdated technique. Nobody really uses it much nowadays practically. But it's very easy to study. And back in the day, it was useful. So what people used to use chromatography for was to carry out different tests. Now, let's say somebody has been poisoned. So you are suspecting the food that they ate could contain poison. So what you can do, is you can get a sample of that food separately and carry out chromatography for that. Okay, so when you carry out the chromatography techniques, what that technique will show you is it will show you all the different components present in that food. Then you can check each component separately and see if there's poison in one of them. It will separate everything and give you the original components in that food sample. That way you can test all of those later and see if there's poison in anything of that sort. Okay, that is one of the main reasons people use chromatography for. So in this case, the first, second, and third options are all correct. So your fourth one is the answer. Then we move into the 30th question. So they've given you an equation and they've told you it's a combustion, a complete combustion equation. How do you identify if it's a complete or incomplete combustion? Does anyone know? Yes? You can drop it in the chat also, no problem. All right, so basically complete combustion is, when your ethene or propane or whatever compound, when it burns with oxygen and it gives you carbon dioxide and water, you can call it a complete combustion. If it's an incomplete combustion, you will get carbon monoxide and water, CO and water. Now, when you, if you check your gas stoves and all of that, if you're getting a blue flame, it means it's complete combustion. If you're getting a yellow flame, it means it's incomplete. So probably there is some dirt or dust particles, filling up the gas tube and all of that. So if you clean it, you can most likely get a blue flame back again. Okay, so here they've given you a complete combustion situation. And what is the mass of water formed when 1 mole of ethene is subjected to complete combustion? Now, this is where we use that ratio knowledge I told you about. So here it's already balanced and they've given you 1 mole of ethene and they want to find the connection with water. But remember, they're not asking you for the moles of water, they're asking you for the mass. But the thing is, I told you the ratio is only applicable to moles. So if you need to find the mass, you need to first find the moles and then only proceed. Okay. So let's first write down the ratio. Ethene is to water. So that will be 1:2. They've given you the number of moles of ethene as 1 mole. So the number of moles of water is definitely 2 times that. So 2 moles. So now I know the number of moles of water. I can find the molar mass of water, H2O, we know. 2 hydrogens and oxygen is 16 plus 2, 18. So I can use this equation. N equals simple M over capital M. I can find the mass by multiplying those two. So that is 2 times 18, which is 36. Okay, so there you go. 36 grams. Okay. We move to the 31st question. It's also based on that. What is the correct energy level diagram for the complete combustion of ethene? Now, even if they didn't give you this one here, 1400 kilojoules, since it's on this side, you can say that it's exothermic. But remember, even if they didn't give you this, you should still be able to know that it's exothermic because it's a combustion reaction. Combustion reactions, that is burning reactions, release a lot of heat. So it's an exothermic reaction. Okay. So we know when it comes to exothermic, most of the energy is on this side. The products, the reactants only have large amounts of energy compared to the products. So always the ones with the higher energy go to the top. So definitely not these two. Okay. And then remember, the arrow should always go from reactants to products. Those are the 2 things you need to keep in mind. So that means definitely not this. Second one is your option. Okay, that is that. Then we move into 32. There is a greater chance for a man swimming in the water with gas bubbles at the base of a waterfall to drown. What is the reason? Okay, so if this is your waterfall, if this is the place where all is falling down, So if you really want to swim, it's better you swim somewhere a little away. If you were to swim right below this, what will happen? We know when you go into water, you have an upthrust, right? So then water will push you up. But if you're right below this waterfall, remember this waterfalls are normally high structures. So therefore the height is also very big. So we know when it comes to water, when the height increases, temperature, the pressure increases as well. That's why I think you've studied about the that experiment here in a jar where they put different holes and filled it up with water. The ones at the top, small amount. The ones at the bottom come out more because the ones at the bottom have a higher pressure because the height is increasing. So here, since water is coming from top to bottom, there's a big height involved. So definitely when the H is high, the pressure is also very high because pressure equals H rho G. So if this is very high, this will also become very high. So imagine when you have water falling on you with that much of a force, that much of a pressure, definitely it will, overcome this upthrust and push you down itself. Okay, so that is why a person swimming right under the swimming pool, under the waterfall, has a very high chance of drowning. Okay, then 33rd question. Okay, so the 32nd one, it's option number 2. Because if you're swimming right under the waterfall, there's a decrease in the upthrust because the waterfall's power is much more. Okay, all right, then 33. When a sound wave emitted by a loudspeaker propagates through air, what happens? Okay, so now remember, when it comes to a sound wave, frequency always remains the same. It never changes. Okay, so therefore this is wrong. Wavelength always remains the same. That also never changes. Okay, so that is also wrong. What about velocity? You know the equation V equals F lambda. I think this, sometimes they give it to you like this, a V and a lambda. Sometimes you might be used to this equation. Whatever the case, the equation is velocity equals frequency into wavelength. Okay, so here frequency also won't change. Wavelength also won't change. So definitely speed also won't change. Because why? The sound is traveling only in the air. Now, if it was traveling from air into water, if they give you something like that, then it will change. Then the frequency will change, velocity will change. But here the question says it's just traveling through air itself. So because the medium is not changing, these three will not change. But what about amplitude? Amplitude is the loudness. Loudness changes, right? Now, if you're standing in one end of a football pitch, and if you shout, definitely a person standing at the other end is not going to hear it. Or even if they hear it, it's going to be a very, very soft sound, even if you shout with all your energy. Why is that? Because as the sound wave travels through the air, the amplitude decreases. Normally, we show sound waves like this, right? We show it as decreasing like this. Why is that? Because at the beginning, high amplitude. Then it's low, it's reducing. And we know when amplitude reduces, loudness reduces as well. So therefore, amplitude decreases. Option 4 is your answer. Okay. All right. Then 34. Why is limestone added to the blast furnace during iron extraction? We know when it comes to iron extraction, you have a set of raw materials that we use, that is limestone, calcium carbonate. Then we use hematite, the iron ore, and we also use carbon. Okay. So in this particular situation, why do we add limestone? It's option number 3, to remove certain impurities in the iron ore. Now, I'm sure you all remember something called slag that we speak about in iron extraction. So we know slag consists of all the impurities, calcium silicate, calcium aluminate. Those are all your impurities that will be there in your slag. So from where did the calcium come to form calcium silicate, calcium aluminate? The calcium came from your calcium carbonate in the limestone. Okay, if the calcium did not come, then it will be very difficult for you to remove the impurities and separate them as slag. So therefore, we add limestone in order to help us get rid of the impurities to increase the purity of your iron. Okay. So that is option number 3. 35. Which of the following has the greatest effect on ozone layer depletion? That is your CFC gases. If they asked you which has the greatest effect on global warming, we can go for carbon dioxide gas, because global warming is basically increase in the global temperature. So that is definitely due to carbon dioxide gas. But ozone layer depletion is basically, the destruction of the ozone layer. That is mainly due to CFC gases. So even though nowadays CFC gases are banned a lot in a lot of the countries, in lots of industries, still people use CFC gases for, decades, long time ago. I think somewhere around 2005 or something only, it was, fully banned from the world. So until that, people had been using CFC gases. So all of that CFC gases that gathered in the ozone layer is still there. And they're still continuing to destroy the ozone layer. So even if we don't use CFC gases nowadays, because of all that was used long time ago, the ozone layer is still getting destroyed. Okay, so therefore, greatest effect is your CFC gases. What is the gas contribute for acid rains? For acid rains, you have SO3, sulfur trioxide. Let me give you a list. You have 4 main gases: SO3, SO2, NO2, NO. Sulfur trioxide, sulfur dioxide, nitrogen dioxide, nitric oxide. These are the 4 main gases that contribute to acid rains. Why? Because when sulfur trioxide mixes with water, it forms sulfuric acid. We know that sulfuric acid is a very strong acid. When NO2 mixes with water, it forms nitric acid, again a very strong acid. So definitely they cause acid rains. Okay, 36. What is the true statement about the 2 atoms given here? Okay, the number of electrons is equal. So in neon atom, it's an atom. Okay, so these are important words. Since it's an atom, it has atomic number of 10. That means its number of protons is 10. And because it's an atom, that means no electrons were removed or added. That's why they use the word atom. That means number of electrons is also 10. Now let's come to this side. Now it says ion. That means either an electron has been added or removed. And there's a positive charge. So therefore we can conclude what happened, that an electron has been removed. Okay. So again, atomic number is 11. That means number of protons is 11. But now I can't say number of electrons is 11. Why? Because one has been removed. So it will be 10. So therefore, the first option is correct. Number of electrons is equal. Number of protons are not equal. Number of neutrons are also not equal. Fourth one, number of protons is greater than the number of neutrons. Again, no. Okay, so that's a very straightforward question. Which of the following factors affects the pressure exerted by water on the bottom of a vessel filled with water to a certain height? This is where you've carried out some of those experiments in those different shaped glasses to see if the shapes affect. But at the end of those experiments, it was found that it's only the height of the water column that is affecting the pressure. All the others do not affect the amount, the shape, none of those affect. So it's option number 4 directly. Okay, 37 is option number 4. 38, which of the following cells are multinucleate? That is your skeletal muscle cells. Okay, then 39, if you take red blood cells, they don't have a nucleus at all. White blood cells, yes, they can have, but it's not always one. It can be two-lobed or 3 lobes, etc. Cardiac muscles, they're normally uninucleate, one nucleus. But skeletal muscle cells, they have a lot of work to do, so they are multinucleate. Then 39, boiling and evaporation are the 2 ways in which liquid water moves into the air. Of the following statements, which is false? Okay, so for this particular question, according to the mark scheme, they had given all correct because there was more than one correct answer. So if we go into that, temperature remains constant during boiling as well as evaporation. No, temperature is changing during boiling. It will change. It will go to the boiling point. So that is wrong. Boiling is visible, evaporation is invisible. Yeah, most of the time that's true. Normally, if you leave your clothes out to dry, it's evaporation. We don't see the water evaporating. But if you're heating water in a kettle, you can definitely see the steam coming out. So that is true. Speed of wind affects evaporation but does not affect boiling. Again, that's true. Normally, if it's a windy day, the clothes will dry faster. That is because evaporation is faster. But boiling is not much affected by wind. Then fourth option, temperature of water remains constant boiling while it decreases during evaporation. Again, no, that's wrong. It does not remain constant during boiling. So therefore, since you have two answers, this is also wrong. This is also wrong. They had given all for this particular question. Okay. And then the last MCQ, the aim of shortening the food mileage, that is the similar to the carbon footprint. Okay, so why would we shorten it? Why do they recommend you to go for Sri Lankan products and not products from abroad when you eat and all of that? Not because they want to increase the Sri Lankan food quality, but because if you're going to, import food from abroad and all of that, then, all the fuel that goes into transportation. So you are all contributing to increasing the carbon footprint or the food mileage, which is ultimately going to be a very harmful thing for the environment overall. Why? Because just to eat a packet of chocolates, if you are going to import it from abroad, then definitely you are contributing to the carbon footprint in a negative way. Okay. All right. So that's the end of all the MCQs. Does anyone have any questions so far with regards to the MCQs before we move into the structured part? If there are any questions, I'll give you all a minute. You can quickly send it into the chat or ask me anything that you all want.
Excuse me, miss.
Yes.
This is not regarding MCQ, but it's
Mhm.
it's off question. Is it okay?
Yeah, go ahead.
Okay. How does the element tin protect iron from corrosion when tin is less reactive than iron metal?
Okay. So let's go and let me take the whiteboard. So I'm sure you all know the reactivity series, right? So we know the reactivity series is basically an order that is given to show you which is more reactive, which is less reactive, and all of that. So I'm not going to give you the entire reactivity series, but here we're just focusing on a few important metals. So like she said, she was asking me about how tin is used. So if you look at the reactivity series, you would notice that tin is below iron. And then you have something like zinc above iron. Okay. So people, when they need now rusting or corrosion is something that's going to be a very harmful effect on on our vehicles or buildings or whatever. So sometimes people coat their vehicles or buildings or their items with zinc, what we call as galvanizing. But sometimes people also coat it with tin. Okay. Now the thing is, there are different ways in which we prevent rusting, right? Sometimes we paint it, sometimes we apply grease, or sometimes we apply a coating of zinc. Actually, out of all of them, applying the coating of zinc is the best. The galvanizing process is the best. Okay, why is that? Because zinc is present above iron in your activity series. Therefore, if you coat it with zinc, zinc will act like a shield for the iron. So even if the zinc piece gets scraped off a little, it's still going to be a shield. Now it's like this. Let's say we're talking about a ship. Okay, we know a ship is always in salty water. So we know salt will increase the speed of rusting. Then what will happen? We would expect this ship to rust very quickly. But the thing is, no ships survive for a long time. Why is that? Because they fix big chunks of zinc or magnesium to the bottom of the ship, to the hull, the ship's hull. So what happens? Magnesium is also above iron. So these metals, magnesium, zinc, they're acting like a shield. So when those metals are there, the salt water is not going to affect the iron in the ship, but rather they only go and affect the metal here. They will go and corrode the magnesium or the zinc. Okay. So therefore, iron is protected. That is why galvanized items are a little expensive, because even if there's a small scrape, even if a small piece is cut off, still the remaining parts will get corroded and protect the iron. That is why you need to replace it frequently. After this entire part is corroded, you need to throw it out and fix a new piece of zinc or magnesium. That way you can save the ship for a very long time. That is so that therefore that's one of the best methods. But coating with tin is also a way of protecting, because remember, it's a coating. It's similar to painting. So we know if you paint your bicycle, let's say it's a bicycle, if you paint your bicycle, you can prevent rusting. But the dangerous part is if there's a small scratch or something like that, immediately the air and the water can come into contact with your bike from there, and it can start rusting afterwards. So from inside and all, it will get rusted. But if your bike is galvanized, that won't happen. Okay, because even if there's a scratch, the zinc is very strong and it's preventing the iron from getting corroded. But if you coat it with tin, as long as you look after it carefully without getting any scratches, the tin also will prevent the iron from getting corroded. That doesn't mean the tin is acting like a shield like zinc, but rather it's just acting like a coat. So whether you coat it with tin or paint, doesn't matter. They're all acting as the same. Is that clear, your doubt? You have asked me that?
Yes, miss, but
Okay.
tin is less reactive, ne? So it
Hmm.
becomes the cathode of the cathode, and iron becomes the anode. So won't it like corrode?
Yeah, that's the thing. So your iron is totally covered, right? Your zinc, your tin is the only one that's open to the environment. Your iron is covered. So the more reactive one is sort of covered. So it's like if you have two precious things, you keep the most precious one covered. So there nobody can have a look at it. Similar to that, here you're keeping the iron totally covered by your tin. So even if it's more reactive, it doesn't matter because it's covered. It definitely has no way of coming into contact with the oxygen or the water vapor. So we know those two are important for rusting to happen. So if it doesn't come into contact, then no problem, right?
Okay, miss, thank you very much.
Okay, fine. Okay. So when supplying electricity, okay, so in this particular question, remember, they are checking whether you know your idea of forward bias, reverse bias. Okay, so we know, let me go to one of your textbooks. This one. This one. So you know when it comes to something like this, if you have it forward biased, you will have your electricity flowing through and your bulb lighting up, your device working, all of that. If it's a reverse bias setup, you will not have such a thing happening. So in this particular situation, only the first one is forward biased. Only in there, you can have a direct flow happening like this. But in all the other cases, this is in a backward direction. Here you have it in another manner. So again, this something like this also cannot happen. Okay. So therefore, only the first one is the viable option in this particular situation. Okay. So that is why out of your options, only in this first particular setup, your electric equipment is going to work, because only there the electricity supply is happening.
Excuse me, miss.
Yes.
I have another question.
Mm.
How can we determine the current direction in alternating current dynamo?
So the word itself says it's an alternating current dynamo, right? So that means you don't have a fixed direction. It's something that changes back and forth. So first of all, you can't fix, fix a particular direction and say this is the direction. So it all depends on one particular instance. So most of the time when it comes to a dynamo, let me take a diagram of it. Where is it? When it comes to a dynamo, yeah. So now even when you've studied in this particular lesson, you would have noticed that you talk about particular instances, right? We talk about one instance where it's working in a clockwise manner, and then we talk about another instance where it's talking about an anti-clockwise manner. Okay. So therefore, if you're talking about directions, they will give you a fixed situation where whether it's clockwise or anti-clockwise, and then you can use your Fleming's rules and find out the direction of current. Okay. If it's a direct current, it's a different story. It has a fixed direction. But like the name says itself, it's an alternating situation. So you need to sort of stop it, pause it, or freeze it at a particular point, and then only consider the direction. Okay.
Okay, Miss. Thank you.
Okay. Can I share the? Yeah, please. Hmm. 35. Why are high voltages and low currents used to transmit energy over long distances? Okay. So when it comes to what is this Ohm's law, we have the equation as V equals IR. All right. And then we also have the another equation that you all have been given for electrical energy, I believe, as VIT, if I'm not mistaken. Right. So in this particular situation, so if we use Ohm's law, if your V is very high and if your current is very low, in order to balance things out, your resistance has to be very high, right? So in this particular situation, it's like this, right? Now, when you have your energy being transmitted through long distances through the wires, so we know when the energy keeps traveling, you will have a certain amount of energy loss. That's something that's inevitable. We can't avoid it. But in order to increase efficiency, we need to try to conserve as much of that energy as possible to make sure we lose very less energy. That way, more of the energy is going to reach the other end of it, and the efficiency is high. So in order to increase efficiency somehow or the other, you need to reduce the heat loss, because we know when something gets heated up, automatically energy loss is very high. That's why normally nowadays we don't even use the filament bulbs, because when you provide a certain amount of current, it will give you light. At the same time, it will get heated up very quickly. And that way, it's having a lot of heat loss. So when you have a lot of heat loss, automatically the efficiency also reduces. At the same time, the long lasting nature of that particular device also reduces. So if you want to, now these big wire cables and all of that, you can't be frequently changing it at the same time. If there's heat loss, it's going to cause all electricity problems and all of that, right? So that is why this particular setup is used to somehow or the other to increase the efficiency. Hope that is clear. Right? Okay, the fourth question. So this is a physics related question. Teacher has provided the following materials, and based on that, the students have set up a circuit as shown below. Okay, so it's an incomplete circuit diagram. There's a few things to be done. By what name is the way the dry cells are connected to the circuit shown? So we know when it comes to a circuit connection, you have two different ways in which you can connect, either a parallel connection or a series connection. So in this particular setup, the cells are connected one after the other. So this is a series connection. Okay. Then draw in the circuit diagram the standard symbol of the equipment that should be connected between X and Y. So from the list given here, you can see that everything is included except your ammeter. So we include the ammeter over here. Remember, when it comes to a circuit, the ammeter is always connected in series. The voltmeter is always connected in parallel. So whenever you have something like this, an external part coming out, definitely that's for the voltmeter. Ammeter is always into the main circuit. Okay, so if you're asked to draw something also, please make sure you consider these points. Then why is a rheostat connected to this circuit? A rheostat, we know, is a variable resistor. So that is mainly to correct the current, the flow of current through the circuit, to control the current coming in. Then state a condition that would result if the switch is kept closed for a long time. So if you've set everything correctly and closed the switch, we know current is going to start flowing through the circuit. So if you keep it closed for a very long time, what is going to happen? You will have current flowing continuously within the circuit. Okay. So when that happens for some time, your circuit is going to get heated up, especially your wire coil is going to get heated up. So when it gets heated up, it releases a bit of that energy. So there's, less efficiency, and ultimately your batteries can die out. Okay, now even when it comes to an electric equipment, let's say it's the fan or the light in your house, if you keep it switched on for a long time without a break, after some time, you're going to lose the efficiency of it. Okay. Then given here is a graph. This is Ohm's graph. What is the physical quantity represented by the gradient? That is simple. That is resistance. All right. Then part B, the following activity was done by a group of students to find the center of gravity of a metal statue. The head and the 2 feet were placed on the smooth pans of your balance. The reading is given in X as 250, in Y it's given as 150. What are the forces acting with regard to the equilibrium of the statue? So for the equilibrium of the statue, you have the downward gravitational force acting W and the upward normal reaction forces R and S. So you need to include both of them, okay? Because they're talking about equilibrium, you need the downward and the upward forces, okay? What is the reaction R through the point A and the reaction S through the point B? So here they're asking you the value of the force R and the force S basically. Okay, so for R, if X is 250, that is the downward force. Likewise, on this side, they say Y is 150 in the question. Then to balance it out, the upward S is also going to be 150. Okay, then what is the weight of the statue? That is simple. For this entire statue to be at equilibrium, the upward forces should be equal to the downward forces. If I write it down like this, upward forces equal to downward forces. What are my upward forces? R plus S. What are my downward forces? W. So R and S together is 250 plus 150, 400. So that is my W, 400 meters. All right. Then the distance from A to the center of gravity is D, this one. Write the moment of the weight of the statue around point A in terms of D. We know the equation for moment is force into distance. So that would be force is W into distance. But you have a value for W, you just found it out in the previous one. So include that and write it as 400 D. Okay. Then what is the moment of the reaction S around point A? That means from point A, you need to talk about this force like this. Will travel like this. So again, moment is force into distance. This time the force is S. Distance is 2 meters because we are going from A, we are checking S. So the gap here is 2 meters. So you can write it as something like this. And also we know the force of S, right? That is 150. So you can just directly multiply it 150 times 2 and give it as 300. Please don't forget the units, Newton meter. Then Roman number 6, it says the anti-clockwise moment of S around point A, that is 300, what we just found in the previous question, is equal. So let me immediately write it down. 300 Newton meters is equal to the clockwise moment of weight W around A. So that is, they're talking about, let me erase all this and show you. Anti-clockwise moment of S is from here to here. So anti-clockwise it will travel. Clockwise moment is from here to here. Okay, so these two are going to be equal. So for clockwise, W is 400. We don't know the D. So using this, we can find the D. D would be 3/4, 0.75 meters. Okay, it's just a matter of math. Okay, so that's a chemistry question. They've given you symbols of elements in the second period. Select the symbol and write the relevant one. Okay, so here, since they've given you the actual symbols, it's fine, all great. But if they give you, a few random letters to say, okay, this is the symbol at this point, please answer your questions with regard to those particular symbols. Okay, instead of giving you lithium, if they give you a random alphabet like X, please use that letter X itself when you answer the questions. Okay. So out of these elements given, who has the maximum first ionization energy? Please remember your ionization energy graph. Now you don't need to know the exact values and exact points, but at least have an idea about how the graph works. So initially you will have your hydrogen, something like this, then lithium, beryllium, boron, and then you have a drop at boron, and then it goes like this. It's a zigzag shaped curve. Graph. Okay, so you need to keep that in mind. So in this particular case, you've only got from lithium to neon. A tip that you can remember is when it comes to ionization energy, first ionization energy, the highest first ionization energy in a period is always shown by your group 8, and the lowest is always shown by the group 1. So in this case, highest is your neon. Okay. Then when it comes to electronegativity, again in a particular period, the lowest electronegativity is shown by your group 1, highest is shown by your group 7. We do not consider group 8 elements when we talk about electronegativity. So in this case, they've asked you for the minimum electronegativity, so definitely lithium. Diamond is an allotropic form of carbon. Exists as diatomic molecules with triple bonds. Diatomic molecules, you have 3 of them, but out of that, only nitrogen has triple bonds. So therefore, N. Exists as diatomic as well as triatomic molecules, definitely oxygen, because you have O2 as well as O3 in the atmosphere in the form of ozone. Fluorine or nitrogen, you don't have triatomic, only diatomic. So therefore, it's oxygen. Okay, then Roman number 2, write the formula of the compound formed by the combination of lithium and oxygen. That is, we know lithium normally forms a +1 charge. Oxygen normally forms a 2- charge. So it's just a matter of exchanging them. You would get lithium oxide. All right, then from the ions given below, select the cation and anion forms. Obviously, lithium always forms lithium plus. Others are not an option. Oxygen always forms O-. The others are possible, but generally for lithium and oxygen to combine, this is what you will have. Okay, the others are not in your scope at the moment. Then draw the structure of the simplest monomer which can polymerize and contains only elements carbon and fluorine. That is, they're talking about Teflon here. This is your monomer. And when it starts to polymerize, we know this double bond is broken and you will have more and more carbons joining with it. So your monomer is what they're asking for. So you draw it. Then they have given you following flow chart shows a series of reactions carried out starting with calcium carbonate. So they heat it, you will get your solid and V. This is a very common reaction. So I would suggest you please keep that in mind. When calcium carbonate, CaCO3, is heated, it forms calcium oxide solid and carbon dioxide gas. Very common reaction, crops up a lot in your syllabus. So please keep that in mind. And then we know when you add calcium oxide to water, it's a basic substance. Any oxide with water, you will get the hydroxide. So calcium hydroxide. Okay. And then what happens when they bubble this gas through it? You will have calcium bicarbonate. This is what you get. Okay. Even if you don't know the bicarbonate part, please make sure you are quite thorough with the others at least. Okay, so anyways, carbon dioxide is the gas. So when gas is bubbled through X, the solution turns milky. because calcium carbonate is formed as a suspension. This observation is also used as a test to identify gas V. And anyways, we know if you hear the words milky and all of that, it's definitely carbon dioxide. So U is calcium oxide, W is calcium hydroxide. Those are common. Then delete one word printed in bold so that a correct idea is expressed. Solid U is calcium oxide. Remember, metals form basic oxides. So you cut off the word acidic. Likewise, the bond in solid U, calcium oxide. You all asked me at the beginning also about ionic and covalent. In this one, you can see there's a metal calcium, non-metal oxygen. So definitely this is an ionic bond. Then the pH value of an aqueous solution of the gas V. Gas V is carbon dioxide. It's a slightly acidic gas, but still slightly even, it's acidic. So therefore pH is lower than 7. Okay. Then what can be seen when excess of the gas is bubbled through the milky solution? By the reaction between X and V. So if you bubble your carbon dioxide through lime water, normally you get a milky white solution. But if you continue to do that, if you continue to send more and more carbon dioxide gas through that solution, you will notice that at one point, the milky nature disappears and the solution becomes colorless. That is the observation that you can see. Why is that? Because now the calcium carbonate that was giving the milky color is getting converted into calcium bicarbonate. Calcium bicarbonate is not any milky color, so it will appear colorless. All right. So hope that was clear. And if anyone has any doubts, you can drop a message in the chat. Let's quickly complete the first two as well, hopefully. You've been given a table. You need to complete. So W is pretty simple. That is your domain eukarya. X is going to be kingdom Animalia. Then Y would be your pisces, amphibia, reptilia, ave. So Y is mammalia. All right. And then Z is going to be your echinodermata. Okay, that's just a matter of knowing your facts correct. Then name the domain to which living organisms not sensitive to antibiotics belong. That is your archaea. Okay, even if they cause diseases, antibiotics are not going to be helpful. To which kingdom do algae belong? Algae, protozoa, all of them going to your protista. Okay. What is the question? How do we say if a bond is covalent or ionic? Okay. So remember, everybody, once and for all, covalent always means you have only non-metals present. If you have something like HCl, H2O, all of them are 100% non-metals, right? You don't have any metals present. So those form covalent bonds. On the other hand, when you have even one metal present, now we spoke about calcium oxide a while ago. Calcium oxide has calcium metal, oxygen non-metal. If you have a combination of metal plus non-metal, it's ionic. If it's only non-metal, it's covalent. If it's only metal, it's metallic. Okay? Just keep those tips in mind. Then going back to where we stopped, characteristic is given. You need to find out the group of animals with those characteristics. So soft bodies are mainly your mollusca, things like your snails and things like that, mollusca. Division of the body into equal segments is annelida. If they talk about division of the body into 3 main segments, that's your arthropoda. Okay. Then existing in 2 forms, the polyp and medusa, that is definitely your coelenterata, or sometimes we also use the word nidaria. Okay, then part B, they've given you a setup to study something with regards to photosynthesis. So this particular plant, they've kept it in the dark for 48 hours, then take it outside and keep it. But when they keep it outside, they cover one area with a black paper and the other area with a colorless paper. Okay, so what are we testing for in this particular setup? We are testing for how light affects photosynthesis. That's why we're keeping it in the light, in the dark, and then bringing out into the light. Okay. What is the reason for keeping it in the dark for 48 hours? Normally, if you've gone through the experiments given in your book for photosynthesis, for almost every experiment, we always keep it in the dark for around 48 hours and then only carry out the experiment. Why is that? Because we know when a plant is normally green in color, it means it has a lot of food stored in it, a lot of starch stored. So you can't carry out any experiment when the starch is already there. So first you need to get rid of all those starch. So you can't kill the plant, right? So what do? We keep it in the dark. So when it's in the dark, it can't do photosynthesis. So if you can't do photosynthesis, no food. So then what do you need to do? You need to eat all the stored food. Just like, when you're at home, if there's no food if you don't have the money to go out, you need to finish all the food at home. That's sort of a situation. Okay. So this plant is kept in the dark, no light. So therefore, no way to do photosynthesis. So therefore, it cannot make any new food. Okay. So what does it do? It eats up all the food that it has and finishes it off. Then after 48 hours, when you bring the plant out, no more starch is there. Now you can keep it in the light to allow it to photosynthesize. If the starch is there, it's going to be an interference with your experiment. All right. So that is that. Then write the color that can be seen in each of the following parts during the test for starch. We know when we test for starch, we add a few drops of iodine. And if starch is there, it will turn a blue-black color. If it's not there, it will remain the golden brown color of iodine. So if you check for the part covered with the black paper, definitely it will remain golden brown. Why? Because even when you bring it out into the light, you still keep that part covered. So no light is reaching in that area. So no photosynthesis happens there. So no starch is formed there. So it will remain golden brown. The part covered with the colorless paper and the part exposed to direct light, both of them will show a blue-black color. Why is that? Because even if it's covered with a colorless paper, it's still colorless. So therefore, light can come in and photosynthesis can happen. All right. So that is your second question. Then if you were to go back to the first question, they've given you a graph. They've spoken about this particular setup for a school laboratory. In which gas has the production gradually increased during the relevant period? That looks like CH4, right? Methane gas. Then if you look at the next one, how much hydrogen sulfide was present in day 15? Hydrogen sulfide is the solid line. At day 15, it's at 10. Please make sure you write the unit as 10 ppm because it says here ppm. If you don't put the unit, you are not going to get the mark. Biogas is produced by the action of anaerobic bacteria. Remember, as soon as you hear the word anaerobic, what should come to your mind? No oxygen. Okay. So by the variation of the composition of which gas is this happening? So basically, which gas variation is causing this anaerobic bacteria to come into the picture? Definitely oxygen. When you don't have oxygen or very less oxygen, anaerobic bacteria come into the picture. All right. So Roman number 3 is oxygen. Of the types of gases shown which acts as a fuel, that is definitely your methane. It's a flammable gas. And of the waste management principles known as 4R, which principle do we use the biogas? Remember, 4Rs are for reduce, reuse, recycle, and recover. So out of these 4, we normally go for biogas to reuse. Okay. Sorry, for recycling, when you have all your some sort of garbage and things like that, instead of just randomly discarding it, you can actually collect it and put it into your biogas generator and recycle. You're getting your fuel that way. All right. Then part B, fixing of a large number of windows is a noticeable feature in a laboratory. So creating a favorable environment for the laboratory users, yes. So if you have large number of windows, you can have proper ventilation. Okay, that is very important in a laboratory, especially if it's a chemistry laboratory or something like that. Proper ventilation is very important. Then also for proper lighting. Okay, and also to maintain a favorable temperature and things like that. It's good to have a large number of windows. And at the same time, if you talk about the electricity consumption angle, definitely if you have large number of windows, you can reduce the usage of electricity bulbs. You can reduce the usage of fans, air conditioners, and things like that. So that way you can reduce the electricity consumption as well. Okay. Then Roman number 2, it says they've given you a set of steps and you need to fill this up. Maintaining under high pressure the steam produced by the boiling water by burning gas. Here the biogas has chemical energy that is converted into potential energy. Then step 2, operating a turbine. So your turbine is rotated because of your steam. That is definitely step 2 produces kinetic energy. So here you will have your kinetic energy. Then operating an electric generator by running a turbine, that is definitely electrical energy. The kinetic energy is getting converted. So it's basically a diagram to show the energy conversions. All right. And finally, we have part C, where they've given you a list of compounds and you need to match them with the correct point. So contributes to increase the soil pH. We know to increase the pH, it has to be an alkaline or a basic substance. So calcium hydroxide is one of the most commonly known basic substances. So that is what is going to come here, calcium hydroxide. Okay. Then causes an increase in heavy metal consumption. Out of all the options given here, the second one has chromium in it. Chromium is a very important heavy metal. It can affect your brain functioning, lungs, kidney, cancer causing so many issues. So whenever you release chromium containing compounds into the atmosphere, you need to be very, very careful. That's why even in the laboratory, when you carry out reactions where chromium is released, you can't just discard it into the sink like that. You need to discard them in a proper manner. Then contributes to create an eutrophication. Eutrophication, you know, is when you have a lot of algal growth in your water bodies. So, you know, the water looks green in color with a lot of plants. You don't even see the water at one point. That is eutrophication. That is mainly due to the presence of phosphorus. So that is your Na3PO4, especially when you have people washing clothes near the river and things like that. So all the detergents and everything will get washed away from the clothes into the water body. They contain a lot of phosphorus. Okay. So that causes eutrophication. And finally, contributing to smog, photochemical smog as well as acid rain. If they talk about acid rain, you can go for SO2. But here, photochemical smog and acid rain is NO2. Okay. NO2 is a reddish brown gas. That's why sometimes if you've noticed in pictures, these places like Beijing and Shanghai and all of that, when they have smog, it looks, you can't even see the proper buildings. That is because the smog is like a very dark brownish color. That is given, the color is given because of your NO2 gas. All right. So that's the end of your structure paper. In that case, I believe, I think we can wrap up the session here.